All right, here we are. We are rounding the corner. I know this is a long video. So the last thing that we've just touched on at Southwest, we haven't had a chance to touch on it at East End, but we will next week, is returning to our conversation of tangent lines and secant lines. And just a quick reminder, a secant line is a line or a line segment that will intersect your graph twice. So, for example, this line that I just drew is called a secant line, S-E-C-A-N-T, secant line. We also have tangent lines. Tangent lines are lines that are going to touch the graph just once. They are going to rest on top of the graph, or in some cases below it. So let's draw some tangent lines. If you're at home, I'd pull out a ruler, maybe an index card. I want to draw a tangent line at this point over here. I need a line or line segment that is just going to touch the graph at that point. There's my tangent line. This is a tangent line. T-A-N-G-E-N-T, tangent line. What if I wanted to draw a tangent line over here? There's my tangent line. Tangent line is lying below the graph. What if I wanted to draw a tangent line over here? There's my tangent line. I can draw a tangent line over here. You can draw tangent lines anywhere that you want. Just make sure that your tangent line touches the graph once and only once. Sometimes your tangent line will have positive slope, like over here and over here. Over here at this point, we have a decreasing tangent line. Your slope is negative. Over here, at this lowest point, slope is equal to 0. Slope is equal to 0. Slope is positive. The astute pre-calculus student might start to notice that where your function is increasing, we're increasing from here until right about here, all the tangent lines that you would draw to that graph are going to have positive slope. When you hit a maximum point over here, you're going to have a horizontal tangent line. Slope is equal to 0. My graph starts to decrease. All my tangent lines have negative slope. I hit this minimum over here. Slope is equal to 0, and then it starts increasing. Perfect. That is what you can, that's the kind of information you can get if you can determine the actual slope of the tangent line. Great. But how do you actually find the slope of a tangent line if it only touches once? Well, let's see what happens. Okay, so starting with a clean graph, we just had the conversation about how if you can draw the tangent line, if you can see the tangent line is going to tell you the behavior of the function. Where the function is increasing, tangent lines will have positive slope. If you're at a max, tangent line will have slope 0. Where it's decreasing, tangent line will have negative slope. Where you're at a minimum, tangent line has 0 slope. Great. But how do you actually go about finding the slope of these tangent lines? Well, what you do, we're going to have to do this one kind of quick because we're running out of video room here. We're going to pick a point on the graph, and we're just going to call this point A, comma, f of A. The x coordinate is equal to A. The way that we get the y coordinate, it's just f of A. And we're going to pick a second point. That right there, that second point, we're going to call x, comma, f of x. 2 points, a, comma, f of A, x, comma, f of x. Now, if you're paying attention, we've got 2 points on the curve. Is this a tangent line? Absolutely not. This is a secant line. The way we're actually going to get a tangent line out of this is we're going to let this second point get closer and closer and closer and closer. How close? really close, so close that when you connect those 2 points with a line, they're going to be so close you can't tell that there are 2 points. That is where we're going to get a tangent line from. Now, let's go through this thought process. If I wanted to find the slope of the secant line, I like to call it secant, we do a change in y, so f of x minus f of a over x minus a. What is this? It's just change in y over change in x. It's our old friend, the slope formula. Secant, f of x minus f of a over x minus a. What I want is tan, slope of the tangent line, the purple line. What we have to do is we let x get really, really close to a. It's this idea of getting closer and closer and closer from the right and closer and closer and closer from the left that you might start to see the connection there. What do we do? Our notation is it's the limit as x approaches a. That is tan. That's how we're going to find that. So if I want to find the slope of a tangent line at a fixed point, like a comma f of a, we pick a second point, x f of x, and we find the slope, f of x minus f of a over x minus a. Take the limit as x approaches a. Great. Let's actually go through that process and let's find the slope of the tangent line to a curve at a particular point. And what you're going to see is all the stuff that we've been doing with limits is going to pay off, and that's what's going to get us to cross the finish line here. So sadly, this slide did not print out. I'll fix that for the handout, but for right now, we're just going to power through this. So I've got a function, x cubed minus 4x plus 5, and I want to find the slope of the tangent line at x equals 0. In order to do that, the x equals 0 is the fixed point. So I need 0 and I need f of 0. I need to plug 0 into the original function to find the y value. I need my next point, which we're just going to call x comma f of x. And what I need to do is I need to find the slope of the line segment connecting those. That's going to be f of x minus f of 0 over x minus 0. And I want these 2 points to get as close together as possible. So we're going to take the limit as x approaches 0. This is going to give us tan, the slope of the tangent line at x equals 0. Well, let's see what we can do here. Limit as x approaches 0. What is f of x? F of x was given to us to be x cubed minus 4x plus 5. From that, I have to find f of 0. I have to subtract f of 0. F of 0, we go back to the original problem and plug it in. 0 cubed minus 4 times 0 plus 5. That's equal to 5. We're going to divide this by x minus 0. And so we get the limit as x approaches 0. X cubed minus 4x plus 5 minus 5. Those cancel out. We get x. If we were to plug in 0, we're going to get 0 over 0. Uh-oh, it's the indeterminate form. Let's try some algebra. The algebra that we're going to try here, take the limit as x approaches 0. In the numerator, factor out the x. So we get x squared minus 4. In the denominator, we have x. The x that we factored out and the x in the denominator will cancel, leaving me limit as x approaches 0 of x squared minus 4. The limit as x approaches 0 of x squared minus 4 is negative 4. What does that mean? That means that tan, evaluated at x equals 0, will be equal to negative 4. Another way to say that, at x equals 0, the slope of the tangent line is equal to negative 4. Done with that. Part B. At x equals 0, was the graph of f of x increasing, decreasing, or neither? Well, we showed that the tan, slope of the tangent line at x equals 0 is -4. So since that is less than 0, that would tell me that f is decreasing at x equals 0. Done. Nice and easy. C, using this information, find the equation of the tangent line. Well, we're going to be doing this a lot in AP Calculus as the year progresses. There were two ways that you learned to write lines in Algebra 1 and Algebra 2. Y equals mx plus b is your slope-intercept form. Then we have y equals mx minus x1 plus y1 is your point-slope form. We're going to use point-slope form almost exclusively. So let's get used to that one. In order to use this, I need to know the point. I need an x-coordinate and a y-coordinate. We know the y-coordinate is equal to 5. We need a slope. The slope is equal to -4. That's the work that we just did. So what's the equation of the tangent line? Y equals -4, x minus 0 plus 5. And on the AP Calculus exam and every test you're going to take in between, you can leave that as your final answer. We are done with this video. If you can do all of these problems and you've spent the time on the practice multiple choice and free response questions, you should be feeling very well prepared for next week's unit test or the trimester exam, the AP Calculus exam. You are good to go. Congratulations. Thanks for watching.